Good morning, pre-cal. Here we go with Unit 12, Day 4, the last session of notes for the class of 2022 or 2023. It's been fun. Let's get to it. For example 1, if a subscript 1 equals 2 and a subscript n equals a subscript n minus 1 plus 2, then find the value of a subscript 5. So this last class, really this whole unit, we've been using formulas to find a particular term in a particular series. And up to this point, we've been able to use a formula to identify the term of whatever series we happen to be working with. With these formulas today, it doesn't work that way. You have to know, in order to find, let's say, the fifth term of a series, you have to know what the fourth term is. And in order to find the fourth term, you have to know what the third term is. So it gets us started. It says, hey, the very first term of this series is 2. We want to find the fifth term. And I want to stop here because that's the term that we want to figure out. We want to know, what is the fifth term here? Now, in order to do this, they've given us the formula, a subscript n plus 2. This right here, a subscript n minus 1. I don't even know if I said that right the first time. I'm sorry. A subscript n minus 1 plus 2. That's the formula. All that means is this portion where my finger's pointed is, what is the previous answer? So if I'm going to solve here, the previous answer, and then add 2, well, that would give us 4. So the second number in this series is 4. Well, if we're going to figure out, well, what is the third term? Well, the formula is, what was the previous answer? Well, the previous answer before the third term was 4, and now we add 2 to get 6. Back to the formula. What was the previous answer? Well, the previous answer was 6. Add 2 to get 8. And now to find the fifth term, well, we need to know, what was the previous answer? What was the answer for the fourth term? 8, add 2 to get 10. So we now have the answer. Your answer is 10. The fifth term in the series is 10. Now you might be saying, hey, couldn't we have just added 2 over and over and over again? Yeah, you could. You could have done that. But you're going to want to know how to do these steps, because at some point we're going to have to know how to do these steps. So we're learning to crawl so that we can eventually walk and then run. Example number 2, if a subscript 1 equals 7, so they've given us the starting number, and a subscript n equals 5a subscript n minus 1, or 5 times a subscript n minus 1. Find the value of a subscript 6. So let me set up my template. And we'll start here. So that formula to figure out if we need to know the second term, we want to find the second term, it is begin with 5 and multiply by the previous answer, which was 7. So our second term is 35. To find the third term, start with 5, and we're going to multiply that with the previous answer, which was 35. You see what we're doing? So I'm going to get the calculator out for this one, because we're eventually going to encounter some really big numbers. 5 times 35 is 175. Well, to find the fourth term, we're going to take 5 and multiply it by the previous answer. 875. Find the fifth term, we're going to take 5 and multiply it by the previous answer. 4,375. To find the sixth term, which is the one they want to know, we're going to take 5 and multiply it by the previous answer. For a final answer of 21,875. That is your answer. Example 3. This is why you wanted to solve the prior problems the way that we did, even though you may have noticed an easier way. is because when we get to example 3, we're going to want to follow that pattern. So begin with the very first term. They tell us the very first term is 2. We are trying to solve for, well, what is the fourth term? Here's the formula. In parentheses, remember what that symbol means? It simply means what is the previous answer, square it, and then add 5 to it to get the current term that we're on. Well, the previous answer to a subscript 2 is here. So plug in a 2. 2 squared is 4. 4 plus 5 is 9. To find the third term, well, we need the previous answer, square it, and then add 5 to it. 9 squared is 81. 81 plus 5 is 86. Find the fourth term, the one that they want us to solve for. The formula is, what is the previous answer? It was 86. Square it and add 5. And if you did that, you would get 7,401. That is your answer for example 3. Example 4, they've given us the first term of the series. It's 1. They want us to find the third term. It's the exact same pattern as the previous one, isn't it? For example 4, that little notation there just simply means what was the previous answer? The previous answer was 1. Square it, and then add 5. 1 squared is 1. 1 plus 5 is 6. Now to find the third term, we need the previous answer, square it, and then minus 5. Add 5. I'm sorry, I said minus 5. I'm gonna add 5. Sorry. 36 plus 5 would be 41. That's your final answer. Now we get to example 5 where they're introducing something new. I've rewritten the formula here just to hopefully make it stand out a little bit more. We want to start the same way as we have up to this point. They tell us a subscript 1, the very first term in this series is 9. We're finding the fifth term. Now, here's where it gets a little bit different. To find the second term, look at the formula. It begins with n. That number represents what term are we currently on? We're currently on the second term. So we need to start with 2, open parentheses. And remember, this simply means what was the previous answer? Previous answer to this term was 9. And then subtract 3. 18 minus 3 is 15. So that's our answer here. Now we're on the third term. So if we're following the formula, n is now 3 to represent the third term that we're on. The previous answer was 15. Subtract 3. 3 times 15 is 45. 45 minus 3 is 42. Now we're on the fourth term. N represents the term that you're currently on. So 4 times the previous answer, which was 42. Subtract 3. I don't want to chance making an error here, so I'm going to go to the calculator. $165. Now we're on the fifth term. N represents the term you're on, times the previous answer, subtract 3. For a final answer of 822. Okay, this right here gets a little bit easier. Write a recursive formula for a subscript n to the nth term of the sequence 4, -1, -6, and -11. you may be noticing that the difference in all of these numbers is -5. So our answer would be previous term -5. The previous term -5 will help you answer this series. For example 7, you may notice that they're dividing by 6 each time. So our ratio is 1/6. So if we were just to write a formula for this pattern, it'd be 1/6 times the previous term. That's the formula for 7. For example 8, see if you can find the difference in these numbers. And now we can write our formula. Previous term, add 3. That's the formula. For example 9, I'm going to tell you what the answer is. It's D. The answer is D. Now, I'm going to show you how you would get that. You could just use substitution here. So all of this series begins with 9. What we should be able to do is we should be able to take 9, substitute it in here, and that should equal 41. So start with 5 times the previous answer, 9, subtract 4, and that would give you 41. That pattern should continue. Take 5, multiply it by the previous answer, subtract 4, and that would give you 201. So that's how you find the answers here. You just plug them in and see if they work. Try example 10 on your own, see if you get the answer. Okay, now we're on example 11. And these are pretty easy too. Write a recursive sequence that represents the sequence defined by the following explicit formula. Start with, well, what is the first term in this sequence? It's going to be that 4 right there. Now we can build what our formula would look like. Looking in the parentheses there, let's keep that. And we're going to multiply that by a to the subscript n-1. This would be the formula here. You don't technically need the parentheses. I'm just trying to make it obvious that we're taking -5 and we're multiplying by whatever the previous answer would be so that we could find the next term in this sequence. For example 11, I'm going to go back to example 11 for a little bit. I actually skipped a step, but it didn't matter because we got the right answer. Here's what we're going to do here with this next example, example 12. What you're needing to do with these is for a subscript 1, what we're going to do, sorry, you couldn't see that, is we want to figure out what the first term in this series is. So what you're supposed to do is everywhere you see an n, see in our formula, n right there, you're supposed to plug in a 1 because we're trying to find the first term. So that's why we plug in a 1. And then simplify. So be careful with these. The number that begins this series is actually -36. So our first term is -36. The formula from here is pretty easy. Just take the number in parentheses, multiply that by a subscript n-1. So we want to do the same thing here with example 13 to figure out, well, what is the first term? Let's take the current formula and everywhere we see an n, plug in a 1. So this series begins with the number 5. Now to come up with our recursive sequence, we're subtracting here. If you look at the formula, 8 minus 3 times n. we're subtracting. So take whatever a subscript n minus 1 would be and subtract 3. Now we have the starting term. Now we have the formula. For example, 14 is what you could do. They tell you what the first term is. The first term is 10. To find the second term, we could take 10, substitute it into the formula here. Previous answer plus 2. Our previous answer was 10. Add 2 to get 12. So we're adding by 2 every single time. So in order to build the explicit formula, this is the recursive. In order to build the explicit, start with the very first term, which was 10, plus the difference times n minus 1. And now that looks like something that we did day 1. We went from recursive to explicit. This is an acceptable answer. Also, you could distribute the 2 throughout the parentheses and then combine your like terms. 10 minus 2 is 8 plus 2n. I'm almost certain Delta Math will accept either of these. This one here, a subscript 1, they tell us it is 5. So if we're going to go from recursive, which it's currently in, to explicit, we could start with starting term times the ratio, which they tell us, raised to the n minus 1. And now that looks like what we did on day 1 of our notes. Number 16 is very similar. Try that one on your own. And then for 17, let me change my page here. Lillian is a teacher and takes home 53 papers to grade over the weekend. She can grade at a rate of 9 papers per hour. Write a recursive sequence to represent how many papers Lillian has remaining to grade after working for n hours. So this one would start a subscript 0 is equal to 53. We start here because we haven't graded anything yet. It wants us to come up with a formula for afterwards. So a subscript 0, it would represent our starting point, 53. Now from here, this is going to be a subtraction problem. This is very similar to those word problems we did. I believe it was either day 1 or day 2. I can't remember. But anyway, this would be a subtraction. This would be a arithmetic word problem. That's the word I was looking for here, because we're consistently decreasing our workload by 9 papers every hour. So just start with a subscript n minus 1, subtract 9. You now have your formula and you have your starting point. And then last, the bouncy ball. A bouncy ball is dropped such that the height of its first bounce is 5.75 feet and its successive bounce is 77% of the previous bounce's height. Write a recursive formula to represent the height of the nth bounce of the ball. Well, the first bounce of the ball was 5.75. The reason why we can start a subscript 1 here is because that is the first bounce. From that point on, its successive bounce is 77% higher. So just convert that to a decimal and multiply that by a subscript n minus 1. We now have our starting point and we now have our formula. Have a good day.